submit your answer even if it's incorrect. So this is our warm-up today. So we're going to write the letters of each rock layer from oldest to youngest. Now, here's the thing. We're going to assume the intrusion is as old as possible. So hopefully you opened up your notes and you looked at what the heck is an intrusion. And so right here, B is an intrusion. It's lava that cut through the rock layers but didn't form its own layer, okay? Now, in order for B to do that, and for it to be the oldest as possible, J and G had to be there first. Remember when we talk about the law of superposition, remember we had the winds and the storms and the floods and the droughts, and we had all these layers laying on top of each other. The oldest layer is going to be at the bottom. The youngest layer is going to be at the top. So the oldest layer in this drawing is going to be G. Then it's going to be J. Then B is going to come along and cut through them for it to be the oldest. Let's see if anybody, no. Oh, close. Some of you were close. Samuel, you had to do a wild guess, not just put, I don't know. You need the chart. What chart? G, J, ooh. Okay, actually I have a couple of you that got that. Then the next layer would be C, I, E, H. They just go in order going up here. Then we have F, but then notice that A cuts through all those layers. So I know that all these layers had to be there first, and then A cut through there. And the only way A could make its own layer out here is if D wasn't there yet, okay? So then it would go F, A, D. D in this case is the youngest layer. Ooh, close. A couple of you were really close. You had this ending switched around, or the C. Okay, pretty close. So the oldest, is G. You can change your answer if you would like. That's fine. I saw all of you. I'm just missing Drew, which I think he's not even with us. Unfortunately, that's going to hurt his participation scores a lot. Drew, I hope you join us soon. You're hurting your grade, okay? So G, J, B. That intrusion cuts through those layers. Then it goes C, I, E, H, F. Then A can cut through all of those layers, make its own layer, and then D can lay on top of it. So the ending is F, A, D for this one here. Okay? Questions for me? All right. So we just went over a lot of stuff that was probably really confusing. We already talked about B. B was the intrusion. Volunteers, what's A? What do we call A? Volunteers to raise your hand and talk with us. B is the intrusion. Lava cutting through the layers, but it doesn't make its own layer. What would A be? Angelica, what's A?
We called it an extrusion, right?
Extrusion. Good. What are these little pebbles called? What would those guys be called there? Audie, what are those little rocks called?
Unconformities.
Close. Close. Samuel?
Inclusion.
They're inclusions. Inclusions, think of that like they're included, right? Just these are pieces of older rock found inside younger rock. So we have an intrusion. B is intrusion. A is an extrusion. The little rocks are called inclusions. There's one more exception to the rule here. Armand, do you know what I'm talking about? What's the one thing that we need to talk about?
The unconformity.
Can you tell me what an unconformity is, or maybe where it is in this picture?
It's the layers D and F.
Okay, so an unconformity is when much younger rock is touching much older rock. So these guys are both considered pretty young. Where do you think, Sahil, where do you think the unconformity is?
Where E and or where I and F are touching.
Okay, so notice I is much older and it's touching F, where it's much younger going on here, okay? So that's where your unconformity would be. Unfortunately, these rocks are in the way, but right here, where I, older rock, is touching F, much younger rock, okay? Questions on that? All right, is that period one? So let's review everything we've learned so far. We sort of just went over this next slide here. And why aren't you going? Interesting. It's because I'm recording. Oh, because that's not my slide. So we just went over the law of superposition. Remember, the layers on the top are the youngest, the layers on the bottom are the oldest, unless you have these exceptions, which we just went over. We are in we are in our unit geological history, and we started this unit looking at the rock cycle. And we know that the rock cycle is when these three types of rocks all transform into each other, and they're going to do that through these different processes. Now, this process is very slow, but we know that the only way to get igneous rock is by cooling off molten magma. The only way to get metamorphic rock is by igneous or sedimentary rock becoming heated and pressurized. The only way to get sedimentary rock is by compacting or compressing sediments. Now, sediments can be formed from any of the three rocks becoming weathered or eroded for this one here, okay? We also then looked at plate tectonics. We realized that the crust of our planet is known as the lithosphere. It's broken into plates. And right underneath the lithosphere is called the asthenosphere. It's that molten lava layer. And this molten lava layer moves in circles, and we call these convection currents. And because this lava is moving around, it causes the lithosphere above it to move in different ways. We know that we have three different boundaries depending on how it's actually moving, okay? Yes, all these slides are available to you already. Transform, these slides will be available after fifth period, okay? Transform is when your plates slide side to side. These guys cause earthquakes. Divergent is when your plates move apart, and it actually causes sea floor spreading. And then we have convergent boundaries. Now, we have two types, because if you have an oceanic plate, it's more dense. It's going to subduct or go under the continental plate. It's going to heat and pressurize into molten magma, and this is what causes our volcanoes. Another way to have a convergent boundary is by them both being continental plates, and they crash into each other, forming mountains. Okay. Then, before we went on winter break, again, we looked at relative ages of rocks by comparing the oldest layers to the youngest layers with those exceptions, right? But there's another way to get a better idea of how old rocks are, and that's much more complicated. That's looking at the radioactivity of these rocks, and then you can get an idea of how many millions of years old they actually are. Okay. Whew, we just recapped everything we've done. Any questions regarding the unit so far? Okay. So when we come back from our break, we are going to revisit that rock drawing that you submitted. Remember that rock drawing you did on Thursday? So if you want to have that open and ready, you can, but it's time for our first break. So get up, stretch, get something to drink. Let's do 3 minutes. Here we go. All right, come on back. If you're one of the few people who need your camera off, please check in with me. Thank you, Adi. All right, so, oh, I didn't pause the recording. Oh, well. Okay. Do you remember this rock drawing? Okay, go ahead and open it up. It's in 3 weeks is the end of the semester. So in 3 weeks, we're halfway done with the school year. Okay, thank you, Bailey. Izzy, are you here? Just half. Yeah, we've gone through half of the school year. Drew, are you with us at all? Poor Drew is going to be labeled as a cut from the class. No, 1/4. We're in the second quarter. We're almost done with the first semester. First semester is first and second quarter together. Okay. All right. I want you to open up your rock drawing. You submitted this before we went on break. And as long as you submitted something, you got credit for it. Okay. Some of you guys did it on paper. Some of you did it using the classroom screen option. You did it electronically. Some of you did a pretty decent job. Some of you did not, okay? So I want to go through this with you step by step, and I want you to include this in your notes, okay? Because this will be a visual for you to know the law of superposition and the different exceptions that are there, okay? So I already gave you credit for submitting it the first time. Now you can either edit it. I don't want you to unsubmit it. I just want you to look at what you already turned in. Can you do that? Are you able to just look at it? Yep. Okay, good. But now in your notes, add the correct answer. So we're going to do it together. Okay. So I actually need to open this up because we're going to draw, or I'm going to draw with you. Okay. Let's see. Okay. So the first step is to start with layer C. So first step, paper with layer C. Let me open this up. So we did the first couple slides together last time. I'm going to go ahead and draw a layer C here. Okay. We did the first two steps together last time. So second one, 2 rock layers older than C and label them A and B. So you all should have this first couple parts together. And I'm drawing it with my mouse, so let me give myself more space here. Again, it doesn't have to be perfect. So there we go. We did this first part together last time, and then you were supposed to finish the rest and submit it. Again, I already gave you credit if you submitted something. Now we want to put this correct format in your notes. Okay. Number 3 now, draw 3 rock layers younger than C and label them D, E, and F. So 3 younger, that means they're going to go on top. 1, 2, oop, I ran out of space, and 3. Again, not beautiful, but doable. And we're going to label those D, E, and F. Stop me if you have questions. Okay, let me clear your hands. Number 4, draw an intrusion through the bottom layer and partially through the next layer. Okay, and label it intrusion. So an intrusion, remember from our warm-up, an intrusion is going to be a part where the lava cuts through the layers but doesn't form its own layer. So we're able to, I'm going to use a different color here. I'm going to go just through the middle. And I cut through here. And instead of erasing, I'm just going to color in the whole thing. Ooh. Can you, Miss King? Yes. Okay. So then I'm going to just label that. This is an intrusion. And I know you can get fancy with like text and stuff, but I'm too lazy. Okay. Now, question for you. If I put my intrusion on the left side, will I be wrong? No. It just has to cut through the bottom and enter the second layer. What if I move that intrusion, I drew it on the right side? Would I be wrong? No. So it doesn't matter where you are, just that it cuts through the appropriate layers. Okay, so if your drawing looks different than mine, that's okay, as long as it's cutting through the right layers. Now it says number 5. This is where most of us were confused. An unconformity developed between a new rock layer and a third layer from the top. So from the third layer from the top, so this is 1 layer, 2 layer, 3 layers. There's going to be an unconformity that forms, and it touches, that means much older rock is touching much younger rock. So I'm going to get my eraser. I'm going to make this a little bit bigger. And I'm going to do it on the side over here. I'm going to go ahead and expose that third layer. Okay. Now I have to draw a new layer. So there's a new layer is going to go, ooh, that's too thick. I'm afraid to change anything. Let me just do this. New layer. And it's going to, ooh, don't zigzag, cut through and touch. Yep, touch this next layer. So right here, I'm going to label this new layer G. This new layer is G. So now I have much younger rock. Oh, let me erase this. This much younger rock is now touching much older rock right there. So this is the younger rock touching the much older rock 3 layers down. And we're going to label this here. This is an unconformity. And I'm running out of room, and your English teachers would be appalled at this, but oh well. Unconformity. Okay. Questions on that? Because I know number 5 is the most confusing. Now, I do want to point out, if you look at the warm-up, they just cut the very top off. So you can do it in the middle, you could do it on the left side, you could do it on the right side. That's perfectly fine. But as long as that new layer G is touching layer D 3 layers down, that's where your unconformity is. Okay. All right. Now we have inclusions formed in layer G. So inclusion. Somebody help me out here. What's an inclusion? How should I draw an inclusion? What does that look like? Armand, what does that look like?
Looks like small pebbles or bits of rock exposed from older rock.
Okay, so in layer G, it says to put unconformity. I can put it anywhere in this layer, but just to save us some space, I'm gonna go ahead and make these green a different color. They're just gonna be like little pebbles, little pieces of older rock here. And these guys are inclusions, like they're included, even though they don't belong. Inclusions. Okay. Now the last piece. The last piece says an extrusion formed on the left side of the mountain, and label it. So an extrusion, remember intrusion cuts through just a couple layers and does not form its own layer, but an extrusion does. I'm gonna go ahead and make this this. Let's see what color. Let's do purple. Go ahead and make this thicker because it's hot lava. It's going to cut through and then form its own layer on top. Okay. So this right here is the extrusion. Let me see. Oops, why is that white? Extrusion. Okay. So make sure you have in your notes these 4 different groups here of exceptions. Again, the oldest layer is at the bottom, the youngest layer is at the top, unless you have any of these 4 exceptions here. Okay. All right. Questions for me? Are you guys still awake? I know it's hard. It's Monday. Armand, is that a hand?
Yeah, I have a question.
Okay.
How are inclusions formed?
A variety of ways. One way could be they were brought up with the lava, like they just tagged along the lava. It could be during a shift during different transform or divergent or convergent boundaries. It could be where a man-made ditch or something made. And so there's lots of variety of options. So when you just have pieces of older rock found in younger rock, then that's what this is here. Okay. Other questions? If you forgot to do the rock layer drawing, will you still get full credit? No, it's late now, so you can submit it. If you didn't do it the first time and you submit it now, you'll get partial credit, but it's better than nothing. Okay. All right. So now this leads us into our new topic for today. Okay. Any questions about your rock drawing before I move on? Okay. So we are going to be doing now an index fossil activity. Okay. So go ahead and open it. It's on Google Classroom. This is what we're going to, this is what we're going to turn in for our synchronous classwork. Okay. We're going to go ahead and do the first step together, and then we're going to take our final break. Okay. All right, so go ahead and open this up. We're going to actually do this together. So today is a little bit different. We are going to use this activity to learn about index fossils. So we're going to do activity and notes together. Okay. So we're going to do the first steps together, and we're going to move the columns up and down. Okay, but they have to keep them in the same order. So you're not going to swap pieces. You're just going to click on them and move them up and down, maybe next to each other. That's okay. But we're not going to change their order. You're not going to flip them around or anything like that. And what we want to do is notice their backgrounds. Notice they're all different. And this corresponds to what type of rock that they're actually found in. So each one of these actually represents like a rock sample. So let's pretend that this rock was found in North America, and this one in South America, and this one in Asia, and this one in Africa, and etc. Right? So we got different samples of rocks from around the world in front of us right now. So what you want to do is we're going to move them up and down to line up the rock type. So if I did that there, that doesn't match. So I'm going to move it the other way. And go ahead and line up the rock layers so that they match up and down. Okay. So when I go straight across, they should all be the same type of rock for this one here. Okay. All right, this is where we're going to pause. We're going to take our final break. And when we get back, then we're going to be talking about this thing called index fossils. Okay. Does that work? Nope. If you didn't get them all lined up yet, then make sure you do that before you take your break. All right, you guys, 3 minutes. Ready? Here we go. Come on back. And let's go ahead and continue. Again, today we're going to be talking about our index fossils. We're adding to our knowledge of geological history. All right, I should see your faces now. Go ahead and let me know that you are back. Thank you, Audie. Thank you, Bailey. All right. Drew and Izzy, you guys should be back also. Thank you. All right. So we have our rock layers in order now. And again, each one of these strips represents a rock, multiple, like a big chunk of rock from different locations around the world. Okay. Now what we want to do is identify the index fossils. But Ms. King, what is an index fossil? Well, I'm so glad you asked. Okay. We now are going to talk about an index fossil. Index fossils are very special. Okay. These guys, now you're adding these to your notes, right? We're doing notes and activity together today. So an index fossil is it's very unique. It's very special because it helps us to define and identify geological periods. Yes, we know the ones on the bottom are older, the ones on top are younger, and we can match up the rock types. But if we have these specialized fossils, we can more confidently identify what time period those layers are from, okay? So there's a few things though. First of all, the fossil needs to be easily recognizable. We have to be able to identify it easily. It's only found in one rock layer, preferably, they say only a few, but preferably only one. If it's only found in one rock layer, we know it's extra special, okay? And it has to be widespread, meaning found in multiple locations around the world, okay? So it's going to help us identify what time period that actual rock layer is from, because these specialized fossils are going to be very unique, very specialized to that time period, that we can confidently say that a sample from Africa or a sample from Antarctica, we can confidently figure out the rock layers and that they're from the same time period if they have the same fossils in them. Okay, so let's go back to our example here. Now, we have all these different fossils. Okay, I'm just going to start from the top left-hand corner. Now, in order for them to be index fossils, again, we want them to be easily recognizable and only found in one rock layer. Okay, that's not the one, this one. Okay, so first of all, I want to go down my row and see if this fossil is in any of the rock layers. It's not, so that's a good sign. Okay, I'm going to just double check the others. I don't see it, so good. It's only in one rock layer. Ooh, nice. And notice that this fossil is in multiple locations. It's in multiple samples of rock. So it's in one rock layer. It's found widespread in multiple layers. This is an index fossil. So there's a couple things. We want to highlight or color this fossil a unique color. Now I tried to do the insert line. I'm going to try this again. It says insert line scribble, and then you can scribble on it. Oh, there we go. And now I can change the color. I'm going to go ahead and make it yellow. There we go. Okay. So I'm going to do that to all of them. I'm going to use the same color. Insert line scribble. And I'm going to scribble on that guy again. Oops, I pushed the wrong one. So go ahead and color those all the same color. And why aren't you doing it again? Why doesn't it want to do it now? That's annoying. So this is what happened to me last period. It wouldn't let me color it. So instead of coloring, if it's not working for you coloring, let's just put a box around it. So I'm gonna box it. You don't have to box if the coloring is working for you. Notice that it's colored though. The box is covering it all together. I have to change this bucket, the fill color, to transparent. And I'm gonna go ahead and change the thickness of these lines to 3 and change its color. I'm gonna go ahead and I'll make it yellow. No, yellow's not good, you can't see it. I'll make it red. So either you can color it or put a box around it. You decide, okay? Now, if I wanna redo this box, I can just click on it and hit Command D as in duplicate it, and I can put it on the others. I wanna color or box all the index fossils of the same index fossils. Yeah, do it to all of them. Okay. For some reason, my scribbling doesn't work very well. If yours does, cool, but make sure they're all the same color. Okay. All right, go faster or go slower? Slower. Okay. I'll give you a minute. It just so happens that the first fossil we looked at is an index fossil. If you feel confident on doing the rest of them, go ahead. I was gonna do one more with you. But if you feel like you got this, go ahead, but use a different color per index fossil, okay? Okay, that's right, Audie. So it sounds like we're ready to move on. I'm gonna look at just the next one in the row, okay? And I see that it's like a pine cone looking thing, and I'm gonna look, I don't see it in any other layers, but I do see it over here. So it's only in one layer and it's widespread. Bing, 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 that's an index fossil. So I'm gonna go ahead and I'm gonna box this one too, but I'm gonna change the color. I'm gonna go ahead and make it purple. No, let's make it different. Let's make it blue, okay? And I'm gonna do that to the other one as well, okay? So it has to be in one layer in more than one location, okay? Now I'm gonna look at the next one. Kind of looks like, I don't know, like a stomach. I don't know, like an organ stomach. I see it here. I don't see it in any other layers, but I see it here. It's in 2 different layers. That's not special enough. I'm not gonna consider that an index fossil, so I'm not gonna color it. It's not an index fossil. Okay. So go ahead now and do the rest of them. I'll give you a hint. There's 4 total. So find the 4 index fossils and color them a different color. Okay. When you're ready, you found all 4, hit go faster. All right, I have 2 of you ready. All right, I'm gonna give you 1 more minute. All right. Volunteers. Can somebody raise your hand? What would be the another index fossil that you identified? So again, there's 4 total. Angelica, which one did you identify?
The one that looks like fruit slices on like 3 from the bottom.
Okay, this guy right here.
Yeah.
Slices, all right. So I see him here and no other layers, but I see him in another location in the same layer. So yep, I'm gonna go ahead and square that one, but change the color. Good, that would be the 3rd one there. All right, a 4th one. Armin?
It's the one that looks like, well, I don't know what it looks like, but it's on the last layer.
The last layer. Somebody last period said it looks like cabbage. And so we're here, the cabbage looking one. You're right. It's only in that layer and it's in multiple locations. Actually, I'm gonna make it, oh, this already is 3. So let's do this, this. So we should have all of these mixed up here. Okay. Like a leaf. Okay. Yeah, it looks like a leaf, sort of. Somebody tell me, oh, any others? Any others for this one here? Somebody tell me, why didn't you pick this like super squiggly one here? Why isn't this an index fossil? This guy right here. Sahil, why not? Why not this guy?
Because it isn't widespread.
Okay, good. It's found in one layer, which is what we like, but it's only in that one location. It's not in other locations. It's not widespread. Good. Thank you. Okay. So now what we're going to do, go to slide 2. Now we're going to delete all the fossils that are not index fossils. Okay. So what I like to do so I don't make a mistake is I'm going to move them. So we have almost looks like a spinning top. This guy. We have like the pine cone looking guy. I like the fruit slices. I like how Angelica said that. The fruit slices. Oh, you know that like that gummy candy. You like that one? The oranges with the sugar on them. Those are delicious.
Yeah, that's what I meant, because they kind of look like those.
That looks good. And then we have like this cabbage leaf thing. Cabbage leaf right here. Oh, it's flipped around. Okay. So now all of these guys, we're gonna delete them. Oops. That was weird. My roof just made a noise. All right. Okay, so we're left with these 4 fossils here. Now, on the 3rd slide is a key, and it tells you how old these 4 are. Okay, so go ahead on your own. I want you to move these from oldest to youngest. From oldest to youngest. And when you're ready, click go faster. All right, and give you one more minute. Again, when you're ready, click go faster. Drew, are you with us yet? Drew? Okay. Let me change your attendance. You don't get it. Okay. All right, so let's look at the third slide together. This one, MYA. Anybody know what MYA would stand for? MYA. Sahil, what does that stand for?
Million years ago.
A million years ago. Okay, so the larger the number here, the older it is, because that was millions of years ago. So as we go down this list, they get older and older and older and older. Okay. So what we need to do on slide 2 is move our index fossils from oldest to youngest. Somebody help me out here. Where would the oldest piece go? Should the oldest piece be on the top or on the bottom? Raising your hand. Oldest piece go on the top, or does the oldest piece go on the bottom? Brianna, which one?
The bottom.
The bottom, the oldest piece. Okay, so somebody help me out here. Which one of these guys is the oldest? We'll start with the oldest to the youngest. All right, Armand, give me the oldest.
The oldest is the leaf thing.
The leaf thing. So let's go here and let me check the key. Yep. When we look at the key, the leaf has the largest millions of years ago. It's the oldest. Somebody else help me out. What would be next above the leaf thing? Are the rest of you awake? Are the rest of you with us? Angel, what would be next? The orange slice thing? Yep. Orange slice thing, good. All right. What would be after that one? Matthew?
The longest one, I don't know what that is, but
Okay.
like a pine cone.
Okay, I'm with you. It looks like a pine cone to me. And so good. That one would be next. And then last but not least, easy participation point here. What would be on the very top then? Angelica?
The last one kind of looks like a top, the spinny one.
Spinny top. I just spent the weekend battling my boys on Beyblades. You know what I'm talking about? Let her rip. Yeah. Okay. So it reminds me of Beyblades right there. Apparently, my youngest has a good one, a good stamina one. Whatever. Okay. But he beat me a lot of times. So there we go. So now my last question to you, and I want you to write it on here, write it on your slide. What law is this? What law? Write it on your slide. And then volunteer. Let me lower your hand so I can get some different voices in here. Somebody help me out here. This is the law. What law is this? Law of Ivan, what's this law?
The law of superposition.
Superposition. My next question for you, I know it's not on your thing, but oh well. why are these special? Let me say fossils. So why are these fossils special? Go ahead and type it on your slide. All right, volunteers, why are these 4 fossils special? Garika?
They're index fossils.
Okay, they're index fossils. Derek, can you add to that? Derek, I don't hear you. I see you trying, but I don't. There we go.
I forgot that these don't have a link. I was gonna say the same as Garika. I forgot what else to say.
Okay. Brianna?
They're in the same rock layer.
They're in those same rock layers. Okay. Who else can add to this? What makes these guys special? Sahil?
They can help you date and organize the rock layers and identify what happened.
Okay. Armand?
They're widespread.
Okay. So, right, these are index fossils. They're found in only one layer. They're widespread, and these guys are so special because they're so unique that we're able to identify the age of these rock layers. Notice that some of these, like this is limestone, but this is limestone also. So just by going off of the rock type isn't very reliable, because this is much younger than this limestone. So not only do we want to have the same rock type, but we also want to have that unique fossil to help us identify the age of these rock layers. Again, though, this rock piece might be from one side of the world, and this is from the other side of the world. So we're able to take samples from around the world and still identify their relative ages and time periods that they line up with. So pretty cool there. Okay. Questions on index fossils? All right. So that is our day for today. Okay. I want to remind you, your goal was to understand index fossils. Check mark. Remember, you had that STEMscopedia assignment. It's not due until Sunday. And if you have any missing or low scoring work, you want to get those done as soon as possible. Again, the end of the semester is in 3 weeks. Okay. All right. Any questions for me?